Turns out there are films worse than Ultraviolet. A couple of months ago, I made a video to discuss what I thought was the worst film I'd ever seen, 2004's Ultraviolet. I thought the film was dull, with a nonsensical plot, it had appalling effects, and worst of all, it had a fundamental misunderstandings of science. But on that video, many people commented that I'd not seen enough movies, and perhaps this is indeed true. But to those people, I have good news. I can now say this. Ultraviolet is the second worst movie on my ranked Letterboxd list, as a new cinematic delight takes its place, 2004's Red One. I am not the biggest fan of the festive period, but even I can admit there are some good Christmas movies, regardless of whether you think something like Die Hard or Lethal Weapon are Christmas movies. Catch me in the right mood and I'll be more than happy to watch Elf, Miracle on 34th Street, or even Batman Returns. Red One is not like any of those films. I never would have guessed that an action movie starring The Rock and Chris Evans about Santa going missing could be so criminally dull and so devoid of joy, though I probably could have predicted that it would be filled with terrible effects. The Rock stars as Callum Drift, the head of North Pole Security, and on the night that he plans to hand in his notice and retire, Santa, aka Red One, is kidnapped by what appears to be a paramilitary group. But this is no normal paramilitary group. This is a paramilitary group run by the Christmas ogre or the Christmas witch Grýla, who originates from Icelandic folklore and is played by Kiernan Shipka, who I will say I think is one of the better things in this movie. She wants Santa, played by J.K. Simmons, to use his magic powers to truly punish those who are on the naughty list. So how does Chris Evans fit into all of this? Well, he plays Jack O'Malley, a hacker and bounty hunter who claims that he can find anyone in the world. And this does seem to be the case, as it is his skills that allow Grýla and her mercenaries to track down Santa's location at the North Pole. To make up for his sins in this act, he's arrested and recruited by Mora, the mythological oversight and restoration authority, run by Lucy Liu. And he must team up with Dwayne to track down Santa, stop Grýla, and of course save Christmas over the course of 123 minutes, where you can feel every single one of those ticking by. That being said, I would be a liar if I thought there was nothing redeeming about this film, and as I said, Kiernan Shipka is something good in it, and one of the best things about the script is that it incorporates many different aspects of Christmas mythology. We have the Western Santa who wears red, has a white beard, reindeer, etc. But we also have things like Grýla, and Krampus makes an appearance at some point. The movie reminds me of something like Artemis Fowl, crossed with Christmas, and if that sounds like your cup of tea, then maybe give it a shot. I'm sure it will be streaming soon enough, most likely on Amazon Prime, as this is an Amazon MGM production. And I would argue that that's a much more suitable location to go watch this film than spending your hard-earned money on a cinema ticket. After watching this movie, I knew I wanted to make a video about it. Mostly because I wasn't expecting to watch a movie worse than Ultraviolet quite so quickly. However, whereas the science parallels between that film and reality were somewhat easier to pick up on, I really struggled to think of something worth discussing. There was some reality-altering technology, but I'm not nearly a good enough physicist to be able to discuss that in any detail. And there is a bit of basic teleportation, but again, my field is cell biology and immunology, so no real help there. Dwayne also uses some size-altering technology at a couple of points in the film, powered by Christmas magic. So maybe I could have done something on size and proportional strength, but we have done a bit of that in previous lectures. So I'll admit, I was a bit stumped. Maybe this wasn't a good film for this. But then it hit me. Pain. Not only did this film cause me emotional pain, but but there was a scene in the movie, spoilers I suppose, where Krampus and the Rock engage in what is basically a slapping competition. We've discussed bruising in the past, but in this lecture we will discuss how a pain signal travels from the site of injury to the brain and how this triggers a response. I'm sure it's of no surprise to anyone that the key mediator of pain signals is the nervous system, which itself is made up of the central nervous system, consisting of the brain and the spinal cord, and the peripheral nervous system, which is the nerves everywhere else. The functional unit of the nervous system is of course the nerve cell or the neuron, a highly specialised cell that transmits electrical impulses from the central nervous system to every organ, every muscle in the body, allowing us to transform both our conscious and subconscious thoughts into action. These individual nerve cells consist of the cell body, which is the area that contains the nucleus and the rest of the organelles that allow the cell to generally function. From this sprouts the axon, a portion of the cell that is specifically adapted for signal transmission, containing a lot of voltage-gated ion channels, all for signal propagation, which we will touch on in a little bit. These axons can vary in length, anywhere from a few micrometers to meters, depending on the type of nerve cell and the species in which it finds itself. Just think of the nerves that must link the brain to the feet, for example, especially if you are very tall. At the end of the axon is the axon terminal, which leads to a synapse, somewhat like a void where on one side you have the axon terminal and on the other side you have the dendrite of the next nerve cell. The greater number of dendrites a nerve cell has, the greater number of inputs that particular cell can receive from many different neurons. On average, each neuron could be connected to around 10,000 other neurons through around 10 trillion synaptic junctions. At the presynaptic terminal, an electrical impulse causes depolarization, the process by which a cell's electrical charge distribution shifts, resulting in the cell becoming less negatively charged than its surrounding environment. And this allows for sodium-gated ion channels to open. This influx of sodium ions allows for calcium ion channels to open and the influx of calcium 2+. This influx of calcium 2+ ions allows for synaptic vesicles to migrate down to the base of the presynaptic terminal and release a neurotransmitter, a chemical that will transport the signal across the synaptic gap, binding to receptors on the other side on the postsynaptic terminus of the dendrite. These receptors are also ion channels, so once bound to their neurotransmitter, localized depolarization occurs in the postsynaptic terminal. Action potentials, or the electrical signal, are all or nothing events. So once the postsynaptic terminal of this neuron reaches the threshold value of -55 millivolts, an action potential will occur, a wave of electrical impulse that will then travel down the axon. Sodium ions continue to enter into the axon until around 40 millivolts, at which point potassium ion channels open and the sodium channels close. As all of these potassium ions now leave the cell, that portion of the axon becomes hyperpolarized, a resting state where no new action potential can be produced. But the wave of depolarization continues down the axon, opening and closing all of the sodium-potassium ion channels down the axon until the presynaptic terminal is reached, as previously discussed a moment ago. All of that is for the chemical synapse, the chemical being the neurotransmitter. But we also have electrical synapses, where the electrical impulse, the action potential, can pass from the presynaptic terminal to the postsynaptic terminal through a gap junction. No chemicals required. So how is the pain signal transmitted? Well, nociceptors, or sensory neurons, fire a signal, an electrical impulse from the affected site. So in this case of Krampus and Callum Drift, the Rock, in Red 1. That is their cheek. And this goes to the dorsal horn of the spinal cord. This impulse is then sent through the spinothalamic tract, a group of nerves responsible for delivering sensory signals, both good and bad, to the somatosensory cortex in the brain. And there it is perceived as pain. This is often described as the ascending pain pathway, and what follows is the descending pain pathway, where a new signal produced by the brain that will either enhance or inhibit the pain perception will travel in the opposite direction back to that site of injury and trigger a response, such as moving your hand away from a hot item or something. So that's physical pain as we've seen in Red 1, but what about the emotional pain that the film caused me? Well, it appears that the majority of the same regions that are activated in the brain by physical pain are also activated under emotional pain, namely the thalamus, the anterior and postcingulate cingulate cortex, prefrontal cortex, the cerebellum, and the parahippocampal gyrus. However, in addition to these is the amygdala and its role in coordinating the limbic system, which is associated with emotional learning. And this limbic system also happens to include the thalamus, which will regulate where the signals go. So for example, watching Red 1 stimulates the thalamus through the optic nerve, which then activates the amygdala. The amygdala will then inform the hypothalamus that we are both bored and a little bit sad, and this will lead to a change in hormone responses, in this case namely cortisol, serotonin and dopamine, triggering the feelings that I feel when watching Red 1. Neuroscience is incredibly complex, and this little lecture only touches on a minute portion of it, but that's one of the wonders of science, in my opinion. It really is just an infinite whole of discovery and learning. Once you learn something new, there becomes more things to discover. So I hope this lecture has got some impulses firing in your brain and you have a good festive period. Thank you very much for watching.